Hello there, Mr. Sutton here, bringing you the Algebra 2 5-6 lesson on composition of functions, and to evaluate these compositions will be our purpose today. So here's what a typical problem for a composition of functions looks like. Here they're giving us two functions, the f and the g function, and they want us to find g of f of 4. So the basic idea with these is a composition is basically plugging the output from one function into another function. So we have to find the value of plugging 4 into one of these functions, and then whatever that answer is, we have to plug it into the other function. Now, in terms of figuring out where to start, we start on the inside, the innermost function, and we work our way out. So in this problem, for example, we would be doing f of 4 first. And for f of 4, that would just be the square root of 2 times 4 plus 1. Which is the square root of 9, which is 3. So this is all f of 4 right here. So if I'm doing g of f of 4, I'm basically just doing g of 3. G of 3 is just going to be 3 squared minus 4, or 9 minus 4, or 5. And that's all there is to it. Now that we've seen a composition, pause the video and see if you can do f of g of 2 using the same two functions. All right, so first we'll do g of 2. That's going to be 2 squared minus 4, which is 4 minus 4, which is 0. That means f of g of 2 is really f of 0. F of 0 is just the square root of 2 times 0 plus 1. That's just the square root of 1, which is just 1. And just for fun, pause the video, and we're going to try this one now. You can plug a function value into the same function. There's no reason you can't. So pause the video and see what you can do with g of negative 2. All right, so for g of negative 2, the inner g here, we've got negative 2 squared minus 4. This is really 4 minus 4, which is 0. And then if I'm doing g of negative 2, I'm really doing g of 0 now. So that's going to be 0 squared minus 4, which is negative 4. So we only did two functions here, but just so you know, you can actually do more than two. You can actually do as many as you want. You just have to spell out what you're plugging in where. For this next set of problems, we're given two more functions. This time we've got f of x is 5x to the negative 1, and g of x is just a linear function, 3x minus 3. They want us to do three different compositions with these: f of g, g of f, and then f of f. They're not making us do g of g, I guess. But they also want us to state the domain. So basic idea with these, it's kind of like the problems we just did where we were plugging numbers in on the inside, only instead of doing like g of some number first and getting another number to plug into f, this time around, if I plug x into the g function, I just get this expression here that's the g function, 3x minus 3. So f of g of x is basically just f of 3x minus 3. So wherever you see an x in the f function, you need to replace that with this. So with that said, pause the video and see if you can finish this one out in terms of getting f of g of x, and also see if you can figure out the domain that goes with that. All right, so we're doing then 5 times whatever gets plugged in here to the negative 1. We could simplify that to be 5 over 3x minus 3. And for the domain, the big issue going on here is that we don't want the denominator of a fraction to be 0. We've kind of dealt with this situation before. So we want to make sure that 3x minus 3 does not equal 0. And if I add 3 to the other side and divide by 3, 3 divided by 3 is going to give us, if 3x does not equal 3, then that means x cannot equal positive 1. So that's our domain for this one. So just as a quick heads up here, you always have to check both the final kind of composition for the domain, but you also have to check the functions that went into making that. So if one of these other earlier expressions had a domain issue, that would need to be included in the domain for the final thing. All right, so with that said, pause the video and try out g of f of x. So we're going to be doing g of 5x to the negative 1 this time around. So plugging that into the g function, we're going to have 3 times 5x minus 5x to the negative 1, all of that minus 3. And then that's going to be 15x to the negative 1 minus 3. And I could go one step further and simplify that exponent so that I have 15 over x, and all of that minus 3. So for domain issues, there's a domain issue with both the final answer and this 5x to the negative 1 that we're plugging in on the very interior here. Both of those have a denominator of x, at least for part of them. So that means we can't let x equal 0 because then we would be dividing by 0. So our domain for this one is x not equal to 0. All right, we'll do one more. Pause the video and try out f of x. All right, so we're plugging 5x to the negative 1 into the f function now, but that is the f function. So instead of doing this 5x to the negative 1, we're going to do 5 and then 5x to the negative 1 to the negative 1. So kind of confusing, kind of weird, but we're going to do it. And in order to fully simplify this one, it would help to apply this negative 1 to the 5 and the x to the negative 1. So kind of split that up so that those are both getting a negative 1. And this looks pretty wild right now, but it actually is going to work out very nicely for us. So we have 5 times 1 over 5 basically, which is just 1, so we can sort of forget about that. And these exponents here are getting multiplied together, so this is really x to the positive 1. So we really just have 1x to the positive 1. Now for the domain, you might be tempted to look at this and say, well, x is just a line, and that has a domain of all real numbers. However, again, we have to look back at the original kind of function and what went into it. We have this 5x to the negative 1 in the original that we know from over here has a domain issue. For this expression, x cannot equal 0 because then you'd be doing 5 divided by 0. So our domain for this whole thing, despite appearances at the very end of this, is still going to be x not equal to 0. For our next set of problems, we're actually going to give them a real-life backstory just to show you how you can kind of apply this in a real-life setting. So let's say that we have the Cheapville hardware store having a special sale, and they're offering 3 discounts. You have to use all 3, but you can choose the order that you use them in. That's the game. So the first one is the Funkadelic discount, where you take the square root of the price of an item. So we have, for that one, f of x equals the square root of x, if x is the original price. Next, we have a Groovy discount, where we multiply the price by 6 and then subtract 3. So we could say g of x equals 6x minus 3. Doesn't really seem like much of a discount if you're multiplying by 6, but if you were dealing with a number that was like less than 50 cents, subtracting that 3 would actually put you in a better off situation. So I guess it depends on the original price. And then finally we have a happy discount where we divide the price by 3. So h of x equals x over 3. So you decide to go Funkadelic, then happy, then groovy, and we want to know how much a $9 hammer will cost after these discounts are applied. We'd also like to know, just in case we want to buy some more things with these discounts, what a formula is for the price of any item after this series of discounts. So g of h of f of x as well. And you might be thinking, wow, 3 functions, but we can do this. So that was the backstory for g of h of f of 9. Let's cut straight to the problem and see if you can do this. Pause the video and give it a shot. All right, so just like before, we start with the innermost function. F of 9 is really the square root of 9. So that's going to be 3. Next, we're going to be doing h of that output, so h of 3. That's going to be 3 divided by 3, which comes out to 1. And then finally, we had to use that groovy discount at some point. So we're going to be doing 6 times 1 minus 3. That's 6 minus 3, which comes out to 3. All right, so that's a $3 hammer, started at 9, so that's a pretty good deal. What can we do to get a formula for any discount, though, if we go in this order here? So let's cut ourselves a little space on the screen here to do g of h of f of x and give this one a shot. Pause the video and try it out. So our first thing we're doing is h of f of x. So we need to do h of the square root function, h of radical x. So that means we're going to be doing the square root of x divided by 3 if we put that in the h function. Next up, we have to do g of radical x over 3. So that's going to be 6 times this radical x over 3 minus 3. And we can reduce this a little bit. 6 divided by 3 is 2, so that's going to be 2 radical x minus 3. And if we want to double check, if we were to plug 9 in here, the square root of 9 is 3. 2 times 3 is 6. 6 minus 3 is 3. And that gives us the output that we got, just kind of doing it a slightly different way instead of the all-at-once approach here. So that's it for this one. I know this last example was kind of wild, so take a moment to compose yourself before you try the problem set. Until next time, Mr. Sutton signing off.